OpenSSF Scorecard. OpenSSF Scorecard is a project at the Open Source Security Foundation. It was first created, I would say, or invented or thought of by Jamie Thomas from IBM, who is the chair of the governing board. And it really has a lot to do with how your GitHub repo looks. So on that, I am going to pass my seat over to Steve Taylor, who's going to go through some of what you need to know about OpenSSF Scorecard. Thank you.
So the OpenSSF Scorecard is, like Tracy said, it's under the OpenSSF working group or project. If you go to the repo, which is the OpenOSSF, which is the main org repo, and then Scorecard, you'll get the installation instructions and stuff like that. One of the things with the Scorecard, if you look at it, it's going to actually report upon, I think, about a dozen things. It was weird. Yesterday, I was looking at some of the data, and they actually added between yesterday and, or what would that be, Wednesday and Thursday, they added a new field. So if we look at what it does, it basically is going to run a series of against your repos. So the repo it's going to look at some certain things, and it's going to give you a score between 0 and 10. 10 being the best. So if you get a 10 out of 10, you're doing really well in that area. Now, one of the things it does, because it has like I said, about a dozen different checks, it'll also go to and average together everything and give you a overall score. So you'll see that you have an overall score and then the individual scores. So one of the interesting things is the data is actually stored in a public database. So the public database is actually on the Google BigQuery, which I did some research on, and it's interesting that the Google BigQuery is actually just a big Postgres database. There's no cost for the storage of the data, but they do charge for the number of transactions, and the number of transactions is way off the chart. So you're not going to run into any issues if you want to do your own BigQuery navigation instead of going through the API. So that's one of the things. I usually use the API directly to query the data, and we'll show that in a little bit. Some of the things that we have is the actual GitHub action. And I'll show you this in a bit what it looks like in our implementation. But because ScoreCard is a Golang program, you can actually install ScoreCard locally and run it from the command line. So what that means is because it's a command line interface, like here you can run it as a Docker image, or you can do, like I said, go pull the images directly or build it directly. You're able to actually implement ScoreCard not only into a GitHub action, but if you're using GitLab, Jenkins, those types of CI/CD tools, you could actually install ScoreCard into those tools and figure out, get your scoring for those types of CI/CD tools. So it's not only limited to the GitHub action or GitHub, but it can expand upon the other CI/CD tools. Or if you just want to test your own repo without publishing things, you can just run it locally on that side. Some of the things that it outputs, here's some of the sample runs. Like I said, it's going to go through and do a few different things. This is the one that was added yesterday, I noticed, vulnerabilities. is a relatively new one that we weren't picking up when we were looking at the scorecard on the Ortelius side. They go through and they break down. Let's see if they have it down here. Where are the docs? GitLab, this is all configuration. Here we go. The scorecard checks. So we have the different scorecard checks. Some of the things, some of them are like pretty hard to figure out how to work with, like the CII best practices. You actually have to go and submit your project to that group to have them check over your project to get in their system. And once you're in their system, then you get the information back from their system. The other one that I've noticed is that a lot of people aren't doing is fuzzing. So, throwing fuzzing at your basically test cases to see how well your application runs with some minimal testing. Other ones that are relatively easy to maintain are pinned dependencies. Pinned dependencies have to get into how your builds work and your actions are handled. What we do is we use Renovate to handle our pinned dependencies. So that's one of the things that we have a Renovate bot that goes out and runs, and it handles all the pinned dependencies for it. This one is kind of one of those weird ones, I personally think, because like I said, we've implemented the Renovate Dependabot action to go out and manage all of our pinned dependencies. So like one of the things that it says is a security flaw is that you go out and pull your GitHub actions using latest, or your Docker images, base images from latest. So what that's saying is you never know what is the latest version. So you have the ability to be corrupted on that basis by pulling in a bad image, for example. But because we use Renovate Dependabot actions, we go out and update and grab latest anyways. So it's one of those things that happens. We always try to use latest, the latest pin dependency. So that one's one of those weird checks, I think personally, that allows that you're basically getting around by using like a Dependabot. Other things that some of the static code analysis that we have, CodeQL. Now, one of the things like CodeQL doesn't exist in GitLab. It may now, but it's hard to set up on that level. Signed releases, we actually ran into a weird one on this front. We actually, because we publish, our publishing is signing Helm charts. And one of the things when the Helm packager goes out and signs your Helm chart, it creates a signed file with the extension PROV instead of ASC. So there are some workarounds that we had to do to publish both file extensions with the same contents on that level. Yep. Yep. So Tracy's saying, make sure if you have any questions, let's go ahead and put them in the chat. And I'll keep an eye on the chat as we're going along. So go ahead and drop questions into the chat, and I could pick them up from there. I'll keep an eye on it. So how do you implement this? So let's go ahead and take a look at Ortelius. Look at our repo. Now we have reusable workflows. So we have our workflow toolkit that Utkarsh put together. And if you actually go into the GitHub folder and workflows, you should see there's a Trivy scan. Oh, we don't implement them at that level. We'll pick one of these other ones. Because it's not a complex, the reason why they're individual is they're not that complicated, so we didn't need to make a complex like our build runners are for building our Docker images. So some of the things, first thing, we actually use a security hardener just to check to see where network traffic is coming from. We're in audit mode right now just to kind of give us a report where things are coming from. Then, of course, you have to check out your code. And then you run the analysis. So this is running the OpenSSF ScoreCard action. Now, one of the things that GitHub has is it has these Serif files, and that's kind of like a generic static code analysis file that GitHub can then upload. And when you upload it, you can actually get the scorecard information off of the security tab here. So if we go into code scanning, code scanning, and our advisories, like here's the pin dependencies that I was talking about that I was showing that showed up. So it's another way to kind of aggregate together the output of the security scans up to this level. Also, you can just look at the raw action. So if we look at the security scorecards, if you want to dive into the details, we could look at our security analysis. Where is the output run analysis? And you can see it's this big messy JSON file of everything that's happening. One of the things that we've recently done is implemented scorecards into Ortelius itself. So if I log on to our console, and this is just our SaaS version, and we're going to go to one of our components. So you can sign up to just off of the Ortelius page or off of the Deploy Hub page to log in, and you'll be able to view any of the Ortelius stuff. You'll see that there's a domain here, global open source. We're looking at some of the Golang packages that are out there. Let's pick this one here. I've spied on what's happening in the Swagger Golang world. So we've taken all that raw data and actually synthesized it and made it so it's readable. So one of the things that we have for this particular package, now this is a Golang package that is a dependency of one of our microservices. So we've actually run the scorecard against the microservice itself, and I'll show you that in a second, but also we've run the scorecard against any of the dependencies. So we'll actually look at the SBOMs, all the plurals in there, and then go out and see if there's any SBOM scorecard data. One of the things that is interesting is you can generate a scorecard for a repo, or you can generate a scorecard for a commit in a repo. And that's important to understand because as the versions bump, you're going to have different scorecards. So if somebody's adding like signed releases here. So in this version, we don't have any signed releases, but in the next version, they go out and fix that. We want to record that they do have signed releases then. So running against a particular commit, is important in the long run for us to be able to do historical trend analysis. So this is the Swagger Golang library. And like I said, we have the overall score, the 4.6, and that's coming through basically the averaging of all the different checks that are being done at this level. I'm going to do the same command from a command line. So let me clear my screen, and here, oops, if I can grab it. So the way the API works, you can just curl against the API. This is your repo name. I actually have a typo in here. We'll fix that. So you got your repo name and then the commit that you're going after. I'm just going to pipe this through JQ so we can get some better coloring. So let's go ahead and run that. Oh. Another typo. Fix my typo there. There we go. So if you look at the output that it's giving us for all the checks, one of the things it's going to give you is the repo name that the output, the scorecard's for, and the commit that we're going after. If you don't pass in the commit parameter, it will give you the commit of the latest one on the main branch. So you'll get a commit back for what the scorecard's associated to, but it may not be for the exact release that you're looking for. If you look at the code review, this is where we got a 9 on the code review, and then it gives you a URL. So let's look at one of these, like CI best practices. Where'd it go? There it is. It gives you the URL around the documentation on how to fix that. I've looked at these and they can be pretty cryptic on what you're supposed to do. You know, they give you basically what they're trying to check and how they look at the scoring of it. But one of the things that I found when you're looking at these best practices is there's no way, it doesn't really tell you how to go and implement the changes that are needed to your repo. Some of them do, some of them don't. Like I said, it says you have to go and earn this other badge, and that's like all it says. It doesn't say how you have to go and fix your GitHub Actions or your code base. So that's one of the frustrating things I found with the scorecard is this is great. I'm getting a 4 out of 6 on some 4 out of 10 on something, but how do I get to the next level? Some of the other ones that are can be interesting. Let's see, fuzzing, license.
Which ones are the most critical that people should implement?
Signed releases, token. Oh, here, this one, token permissions. This one drives me crazy. So, you want to get a 10 out of 10. I'm very, goal oriented. So I want to go and get a 10 on every single thing. But like this one on token permissions, like for our deployments, one of the things on the deployment or on our actions that we actually will go out and generate like our Swagger documentation as part of our build process. So when we go out and build our Docker container, we actually then, after the Docker container is generated, we actually go and run the actual microservice and ask the microservice, give me your latest Swagger JSON file. And when we do that, we get the Swagger JSON file in our build directory. And then instead of it just leaving it on the floor in the build directory, we actually go and run another GitHub action to commit that Swagger information back to the repo. To do that, you need write access to the repo to create a commit and push it in there. Well, as soon as you give your workflow a write permissions, you blow your token permission scoring. So it gets into this weird, I have to do stuff. Not all of my workflows can be read-only, which would give me the perfect score of a 10. But in our case, we actually have to do updates, which brings our score down. So there are some things that that will mess with your head trying to get the perfect score. If we jump back to the point, Ortelius, some of the things that I would say that are critical is it maintained? Is the package maintained? Are there licenses out there? The other one I think that's really interesting is the project signing their releases. So this has to do with all the code signing of the artifacts. And this allows you, from a security perspective, you could say if this package has a bad vulnerability in it or it has been exploited, who can I go find out who talked to, who created it, that type of thing. More of the origin of the coding change is going to come from the signed releases. It's more of a trusted way to consume your packages. Other ones, binary artifacts. This has to do with binary artifacts in the repository itself. So like if you check in a jar file into your repo, instead of pulling in jar files at build time, that one could be of some concern. The security policy has to do with whether there's a security policy file, markdown file in the repo itself. This one basically says if you find a vulnerability, how do you report it to the developers at that level? The static code analysis, fuzzing, some of the CI best practices, they're really hard to get in place. So I don't really worry about those as much when I'm looking at the scoring of an application. So if we actually go look at Ortelius itself, we'll see how we're doing on some of our microservices. So this is one of our microservices, the comp item. And you can see we're a little bit higher. We're at a 7.5. We don't have code reviews implemented on this basically code reviews branch protection in the GitHub world. So that has to do with having folks, multiple people review every pull request. Because our team isn't that, well, let me put it this way. Because our team isn't all online at the same time, making pull requests is hard to do in a reviewed fashion. It just slows things down. So that's why it's basically turned off for code reviews. Like I said, CI best practices, it's something that we need to look into, but haven't figured out how to do that. Signed releases, it's an 8. I'd have to actually go into the raw data to figure out why we're getting an 8 versus a 10. I think signed releases is looking back at the last 20 or 30 releases to see if all of them are signed or not. Packaging, this is another weird one. I don't know why packaging is coming up as a -1. I think it's a problem in the actual ScoreCard scoring. One of the interesting things is we were getting a vulnerability showing up in one of our dependency packages. So here's all the packages that we're pulling in. And I think this may be fixed finally. But we are actually finding a security vulnerability in ScoreCard and some of the other packages that were reporting tools about vulnerabilities actually had vulnerabilities themselves, which is a pretty ironic thing that we ran into. So let me just jump over the chat real quick.
About that problem from going from the artifact back to the Git repo.
Yeah.
Can you repeat that question?
So there was a question, how do you get the ScoreCard information for these packages? So one of the things that we have here is our plural. So plural is basically a universal format for describing an artifact. So if you just do a search on plural, it'll pop up all the syntax. So basically you have the type, and then you have like an org owner, and then you have the package itself, and then you have your version. One of the things when SBOMs kick out, the SBOM will kick out all of the packages and the versions, so we know the plural. But the problem is there's no way to associate a plural to a particular Git repo. So this is really problematic in the Maven world. So if you have a jar file that you're consuming, the Maven POM files have the SCM repos as optional data. So the developers actually have to go into the POM files and add that section saying, this is where our Git repo is, this is how you report issues, this is the website. Most of that in the Java world is missing. So we know in SBOM that we're dependent upon, let's say, log4j and a specific version, but we have no way to go ahead and go out and find the source code repo for the log4j repository. So there's, depending on the language, you can drive them. So like in Golang is very repo commit driven. So Golang's pretty easy. That's how come we were able to look up the plural and the Git repo for Golang programs. Maven Java code, it's optional. In PyPy, it's optional. It actually ends up being in a weird optional field as well. But it seems like Python developers are filling that out more so. So this is one of the catches that we're running into, is being able to go from a plural to a repo and a Git commit. Because without the repo and without the Git commit, you can't get the scorecard, because that's how the scorecard's driven, is based on those two things. Other things I found that's of interest, we actually will, if we look down at our SBOMs here, some of the SBOMs, let's see if I can pick one out. If I see one off the top of my head, let me go over to one of our, which component am I on? I'm going to go to a different component. So all the ones that start with MS are our current releases. The ones that start with sec are the ones coming up in our new release. One of the things I found in these is like libgcc and glibc. These are actually coming from the operating system. So like Wolfie is our base operating system. So Wolfie is basically what ChainGuard is creating as a distroless base Docker image that we get to work from. When we look at Wolfie and some of these OS level dependencies, a lot of the dependencies don't exist in Git. The repository for most of the Debian and Fedora packages are still in Subversion. So even though ScoreCard, you can pass in the Git repo name. So like in our case is github.com. They have no support for Subversion. So there's no way for us to get ScoreCard information from any of the base packages, even though we know how to navigate and associate the package to a repo. We're not able to get the details that we want, but we're doing the best we can at that level. So that's one of the things. As things come across, more things are going to improve. So it's going to be, we're going to incrementally get better along this process. Also, if we, as part of our process, if we have a package that doesn't have a scorecard, when we're talking about the Hero project and the CD events, we can actually go out, find the repo and say, oh, this repo doesn't have a scorecard for it. Let's trigger a new event to go ahead and generate the scorecard for it. And that way we can grab that data down the road. So even though the projects aren't generating the scorecard on their own, we could do it for them as part of our process. So with that, I'm just going to double check chat one more time. Any questions as we wrap up here? All right. Oh, there's a question. What is Swagger? So Swagger is created by SmartBear. So SmartBear, and there's another version called OpenAPI. Basically, that's it. This box right here, the Swagger documentation. So what it does is it will say what are your endpoints, and what do you have to pass for parameters. So this is like your RESTful API endpoint documentation. You'll see here that we have the full rendered Swagger on this part that you can interact with. But also on this left-hand side, we're actually generating a markdown version of the Swagger. And the reason why we do that is if you go back over to our repo and you go to the home page here, and if you go down to the README, you get that documentation about all the endpoints and all the data that's passed automatically. So one of the things that we did in our GitHub Actions is to go out and generate this markdown with all of our documentation basically in it. You'll see here is our OpenAPI JSON. So this doesn't format very well up here. But basically this is the raw data that we're using at that level. So it's basically Swagger is going to be our API endpoint. All right. Any other questions?
I have a question, and you can repeat it for them. Is there data that we get from OpenSSF Scorecard that's going to be important with our metrics and metadata? Is there some that's a bit more important than others?
So Tracy has a question about how can we use scorecard information with metrics and metadata information that we're gathering. So if we look at the data that we're gathering, I would say one of the biggest things when we look at metrics and metadata is going to be if a project is maintained. So because when Ortelius runs and tracks the SBOM data, and then it goes out and grabs the scorecard for every package that's in the SBOM, now we have this big picture view of all the packages that you're consuming for your version of your component. And then that's rolled up to the version of the application. And also, because of the way we organize things based on domains, we can actually start reporting upon, let's say we want to look at all of the Maven code out there. So we have an open source Maven domain, and we can actually see from a scorecard perspective if how many of these jar files are being maintained. So in the case of like the log4j example, there was one maintainer. So that may give us a OpenSSF score of 2. And we can say, all right, out of all these Maven packages that we're consuming, which ones do we need to worry about? So that's going to give us some data to drive some decisions down the road.